Right, this is a review of sets and Venn diagrams, and we're going to cover set notation, special number sets, interval notation, and then Venn diagrams, union and intersection. So here we go. Set notation, there is a lot of symbols that you will have to recognise. So let's say set A is all even numbers less than 10. The way we would indicate that is by saying A equals, and then we use curly brackets for a set. So curly brackets there, even numbers less than 10, well that should be 2, 4, 6, 8, and actually, it's not mathematically perfect, let's go positive. Pretend it said that before. So the key thing to spot here is that we have these curly brackets around a set. Now elements of a set are indicated by this kind of elongated E thing. So I could say that 4 is an element of set A. So that E means it's an element of. It's one of the objects or items in the set. That's what an element is. Size of a set. If you're asked n brackets A, this means how many elements are in A. So in this case, if there's our set A, the number of elements in our set is 1, 2, 3, 4. 4 elements in our set A. So NA means the number of elements in the set. Count how many there are. Subsets and proper subsets. Well, subsets are basically sets that exist within another set. So this is probably easiest with an example. I could say that, let's go for 4, 6, 8. That is a subset of A, because 4, 6 and 8 are also elements of A. So it's kind of a smaller group within a set. Now, you see this sort of line underneath, that means that it could equal it. So I could have actually 2, 4, 6, 8 is a subset of A. If I remove that line underneath, then I couldn't have the 2 there. It has to be a proper subset, means it's not as big as the whole set. A little bit confusing, that explanation, but essentially subsets exist within another set. The universal set is indicated either by a sort of bold U letter or by this curly E. And that is basically everything that we're talking about. So if I was talking about students in a school, the universal set would be all the students in the school. So this is, kind of think of it as everything. All the elements in the whole problem that we're dealing with. Complements of a set. Well, if I've got the universal set, so everything I'm dealing with is the numbers 1, 2, 3, 4, 5, 6. And then I've got this set B, which is just the numbers 3, 4, and 5. The complement of a set is indicated with this little apostrophe, so B with a little dash there. And that means basically everything that is not in B. So the complement of a set means not in that set. That's the crucial thing here. So for example, this complement of B would be all the elements in my universal set that are not in B. So I could have 1, 2, and then 3, 4, 5 are in B, so 6 is the last one. So it means not in. If you see this little dash, it means the the ones that aren't in the B. And useful to recognise that these two together make up the universal set. So B and the complement of B will always make the universal set. If it's not in B, then it's in B, then it's everything. And then the empty set is just a little symbol that's useful to know, and that just means there's nothing in there. So if I was saying, which 40-year-olds are students in the school, that would be an empty set. All right, on to special number sets. Now, this was something that you do need to recognise, this notation. Natural numbers, that's like the counting numbers. So 0, 1, 2, 3, 4, 5, etc., etc. Counting numbers. If you can count the physical objects, so it's basically not negatives. Now, integers are whole numbers, so that's like the natural numbers, but they could be negative. So I could have -7 is an integer, -100 is an integer. Basically no fractions or decimals. So we're looking at whole numbers, positive or negative, anything like that. Unless it's got this plus, in which case it's only positive integers. So z plus means positive integers. So n, natural numbers, the counting numbers. Z is integers, whole numbers. No fractions or decimals. This q here, this means rational numbers. So rational numbers can be written as a fraction or a decimal that finishes. So if I can write it in this form, then it's a rational number. So for example, any whole numbers are, so like 8 is a rational number. If I can write it as a fraction, it's a rational number. If I can write it as a decimal and it finishes, so 7.13, that is a rational number. Irrational numbers are things like pi is the most famous, so this is irrational. And then we've also got things like the square root of 2. So if you're looking for rational numbers, we're looking for whole numbers, fractions or decimals, and we indicate it with this funny q. And finally, r is real numbers. That's kind of all the numbers that you can think of, except for some weird imaginary numbers, which we don't really need to know too much about. It basically means it can be any real number. So if you see this, if you see that you've got a set that's made up of real numbers, it means pretty much every number. All right. Interval notation. So interval notation, that's probably best demonstrated by this example. And this means that x is such that x is between -3 and 4. So this less than symbol means -3 is less than x and x is less than or equal to 4. Basically, that means x is between -3 and 4, but it cannot equal 3, it can equal 4. And then we've got x is an element of r, so x is a real number. Sometimes you won't even see this written because it's kind of a given that it will be there. So sometimes you'll see this and you can kind of just say, okay, I know it's a real number, no problem. If we wanted to draw that on a number line, we start at -3 and we go all the way up to 4. And because it can equal 4, we colour that in. So if something's included, you colour in the dot. If it's not included, it's empty. So it cannot be -3, it can be all the way up to 4, including 4. It could be 4 exactly. All right.